Hello everyone, we are group number 4 and in this video, we will be talking about 3D printing. The world is changing so fast that even the way we produce objects is developing, and one of these developments include 3D printing. 3D printing is a manufacturing process where an object is created layer by layer from a 3D model designed in a computer. We will be explaining the specifics on how 3D printing works, but to give you a rough idea, I will compare it with a traditional printer. In a traditional printer, it will receive data from the computer as input to know what it will print, and then the printer will print the output on a piece of paper. On the other hand, 3D printers also work the same. Although unlike the traditional printer, which is limited to using papers, 3D printers have a variety of choices of materials that can be used, such as metal and plastic, and the output will be a three-dimensional object. Although not all 3D printers look like the one flashed in the slide. There are many types of 3D printers which have different functionalities, depending on the material they use, the durability of the made object, the quality of structure of the object, the cost needed to run the machine, and how fast it can produce the object. Since there are many types of 3D printing, I will only introduce SLA and FDM, which are considered the most established among all of them. SLA printers, or stereolithography, usually have a tank filled with some kind of liquid equipped with a laser, while FDM printers, or fused deposition, have nozzles which you can see in the middle, which are responsible for melting and combining the material. There are many ways we can manufacture things, and it is usually classified into three: subtractive, forming, and additive. Subtractive manufacturing involves subtracting or cutting a raw material to create a new object, such as carving out some wood to make a wooden sculpture. Forming is a process wherein the material is applied with a force or stress, such as compression, to form a decided shape, and a famous example for this is the creation of the model of Shaun the Sheep. And lastly, additive manufacturing. It is the opposite of subtractive manufacturing, because instead of subtracting materials, we are building an object by adding layers of materials one at a time, which is the category wherein 3D printing falls under. There are many advantages in utilizing additive manufacturing, such as removing design limitations, cost reduction, waste reduction, faster production, and reduces error, which is why 3D printing is becoming more popular. 3D printing seems to have so many advantages that it opens multiple possibilities to different companies and fields to improve manufacturing efficiency. This technology is indeed starting to take over the world of production, although there are still problems that need to be addressed for this technology to thrive and have a more special status in the techno field.
So, for the history of 3D printing, the first mention of 3D printing can be traced back all the way to the early 1890s in Japan. In 1981, Hideo Kodama was trying to find a way to develop a rapid prototyping system. He came up with a layer-by-layer approach for manufacturing using a photosensitive resin that was polymerized by UV light. Across the world a few years later, a trio of French researchers, Jean-Claude André, Oliver Dubois, and Alain Le Mahout, were also seeking to create a rapid prototyping machine. Instead of resin, they sought to create a system that cured liquid monomers into solids by using a laser. That same year, Charles Hall filed the first patent for stereolithography, SLA. An American furniture builder who was frustrated with not being able to easily create small custom parts, Hall developed a system for creating 3D models by curing photosensitive resin layer by layer. In 1988, Carl Descartes at the University of Texas filed the patent for selective laser sintering SLS technology. This system fused powders instead of liquid using a laser. Fused deposition modeling was also patented around the same time by Scott Crump. FDM, also called fused filament fabrication, differs from SLS and SLA in that rather than using light, the filament is directly extruded from a heated nozzle. This technology has gone on to become the most common form of 3D printing that we see today.
Now, let's delve into how 3D printers work. 3D printers work via a process known as additive manufacturing, which uses computer-aided design, or CAD. It is a technical way of explaining that a 3D printer builds an item layer by layer using a computer software. While each 3D printer is slightly different, the general idea is to design the object you want to print on a computer first. When you use a 3D printer to produce your product, it comes out in slices. From the bottom up, each little layer adheres to create a single item. Each overlapping thin layer can be quite intricate, with moving elements such as hinges and wheels. This technique is repeated until the model is finished. Some key features of 3D printers include the following. First, it is flexible in design. More sophisticated designs can be designed and made using 3D printers as compared to traditional procedures. Traditional techniques also have constraints which are lessened by 3D printing. Second is its ability for rapid prototyping. The prototyping process is sped up by 3D printing, which can produce parts in only a few hours. This enables each step to finish sooner. When compared to machining models, 3D printing is less expensive and faster at producing components since the part may be produced in only a matter of few hours. Through 3D printing, time may be saved not only during the part's production, but also during the design phase by producing CAD files that are ready for printing. 3D printers are also cost-effective. Since 3D printing takes up less time, operator presence is not required at all times when using them. Due to it only using the materials needed for the product itself, this manufacturing technique also saves material costs. Through 3D printing, time may be saved not only during the part's production, but also during the design phase by producing CAD files that are ready for printing. 3D printers are also cost-effective. Since 3D printing takes up less time, operator presence is not required at all times when using them. Due to it only using the materials needed for the product itself, this manufacturing technique also saves material costs. Lastly, 3D printers minimize waste. When compared to other technologies which use enormous chunks of non-recyclable materials, the manufacture of components uses only the resources required for the part itself, with little to no waste. The procedure not only conserves resources, but it also lowers the price of the materials utilized. This procedure is by nature ecologically benign since it decreases the quantity of material waste required. When you take into account things like increased fuel economy from employing lightweight 3D printed parts, the environmental advantages are expanded. Like most technology, 3D printers also evolved throughout the years. The early 2000s saw repeated improvements and advancements in 3D printing, but it wasn't until 2005 that the technology started to gain widespread acceptance. Innovators and business people aimed to profit as many of their early patents started to expire. As innovative and potent ideas like 3D printed limbs and kidneys emerged, 3D printing started to get widespread attention. As the price of 3D printers continued to drop, the demand for the technology grew and they started to appear more frequently in homes and workspaces. The industrial business has continued to be impacted by 3D printing technologies over the years. No industry insider would have imagined the volume of calls to action from the 3D printing community to deliver the essential materials and products to battle the COVID-19 epidemic in March 2020, when numerous manufacturers and engineers stepped forward.
So moving on to the implementation of our technology, as we all know, 3D printers are used by designers to swiftly produce product models and prototypes, but they are also increasingly being employed to produce finished goods. So as 3D printing is utilized in practically every industry you can imagine, it spans a wide range of technologies and materials. So in this slide, we can see the pictures of the examples of the products made from 3D printing. We have an eyeglass, which is obviously a consumer product. We also have the first ever 3D printed steel bridge in Amsterdam as the architectural structure. Another is a recreated fossil that can be used for educational purposes or replicating ancient artifacts. And lastly, we have the engine of GE appliances that lies under the industrial products that is used for the different construction tools and prototypes. There are a lot more products made from 3D printers that are now used in our everyday lives. So with that, curiosity comes to our minds with the question of what are the most popular brands when 3D printing is the topic. So with the creation and patenting of their stereolithography technique, 3D Systems was created during 1989. The three business divisions of 3D Systems are products, materials, and services. So small desktop and commercial printers that print in plastic and other materials are available along with their 3D printers and software. So next is the Proto Labs that was established in 1999. It is a commercial-grade 3D printing service that was introduced by the company, and once it was expanded, it enabled designers and engineers to transition prototypes into the manufacturing stage. And lastly, we have Faro, which specializes in 3D measurement and other services for the fields of architecture, engineering, and construction. With a 40-year history, Faro began before the advent of 3D printing. So the company's products include coordinate measuring machines, laser trackers and projectors, mappers, scanners, and software. Faro also serves the aerospace, automotive, and power generation industries. So 3D modeling software are all about creating models for 3D printing. Some of them are pretty easy to use, while the other programs are only suitable for professional users with years of experience. So as an example, we have the ever-famous Tinkercad. This 3D design tool is user-friendly for beginners and operates in the browser. The software's straightforward block building concept and a number of core forms can be used to make models. What makes Tinkercad special? It's designed to allow anyone to create 3D printable models and serves as an introduction to solid modeling. So another useful modeling program is SketchUp, which keeps a nice balance between usability and functionality and is suitable for users of all skill levels. So what makes SketchUp special? It is intuitive and powerful with a library of user-generated and manufacturer-produced models. We also have two examples for the printing software tools that focuses on programs that help you execute a 3D print. Cura, despite its name, is an open source slicer that can be used with almost any 3D printer. Because it is simple and quick, the program is ideal for beginners. Most importantly, it is simple to use. Advanced users can access an additional 200 settings to fine-tune their prints. So next is the Octoprint. It is a free, open-source web interface for controlling and monitoring 3D printers. It works with most 3D printers and includes an embedded webcam feed so users can monitor their prints. Prints can be started, paused, and stopped remotely, and plugins for tracking print statistics and sending push notifications on job progress are available. So what lies ahead of 3D printing? A wide range of 3D printers for homes and small businesses are readily available, but they are still regarded as exotic and rather pricey devices. So expect this to change in the coming years, as 3D printers become more and more common in homes, appearing on workbenches, in studios, and even in the kitchen. They may not be found in every home, but those who have them will find them indispensable. 3D printing will lose its unique status as a new technology where everything is different and will be integrated into the entire value chain through the use of automation and industrial IoT concepts on the way to a more sustainable and cost-effective implementation in the manufacturing industry.